Okay, so now we're going to do the citric acid cycle. So we've gone through glycolysis and we now have 2-pyruvate. So 2-pyruvate. It's 3 carbon, 3-carbon molecules, and we need a 2-carbon molecule. We need a 2-carbon molecule to go into the citric acid cycle. So we start off with a little transition reaction. And in the transition reaction, we're going to get rid of one of these carbons. So we're going to cleave off a carbon so oxidize. And when that happens, I can't remember what color I was using before, but anyway, so when that happens, we get an NADH. Okay, we got rid of that carbon, so that went away as carbon dioxide. Okay, so we have 2 in this reaction. We have 2-pyruvate, so we end up with 2 NADHs and 2 carbon dioxides. And then ultimately, we end up with, from the pyruvate, from removing that carbon, we end up with a 2-carbon molecule called acetyl-CoA. And of course, we have 2 of them. Okay, so it's acetyl-CoA that can go into the citric acid cycle. So I guess we'll go like this. Okay, so once we have our acetyl-CoA, if there's a molecule that's present, a certain molecule that is present in the citric acid cycle, then acetyl-CoA can enter. So that molecule is called oxaloacetate. Oxaloacetate. I think that's how it's spelled. And this molecule is 4 carbons long. So if that is present, if that's there, then acetyl-CoA can enter into the cycle, and it will combine with oxaloacetate and create the first molecule of the cycle, called citrate. And citrate then, of course, is going to be 6 carbons long, because we just combined 2 carbons with 4. So once citrate is in there, it is actually converted to another molecule called isocitrate, which is still 6 carbons long. And then that 6-carbon molecule is oxidized. And when that happens, when we get that oxidation, we lose a carbon as carbon dioxide, and we gain gosh, stupid thing. We gain an NAD. All right, so that isocitrate then becomes alpha ketoglutarate. Excuse me. And alpha ketoglutarate is a 5-carbon molecule because we just got rid of one of those carbons. That molecule gets oxidized, and when it does, we lose another carbon dioxide, and we get another NADH, right? And we get a molecule called succinyl-CoA. Okay. Once we get succinyl-CoA, then we now have a 4-carbon molecule, and this molecule gets hydrolyzed. So the hydrolysis, well, it causes the hydrolysis of a molecule called GTP, which comes from this. So the GTP then transfers a phosphate over to ADP, making ATP. So this is the part of the cycle. I cannot get my colors. Okay. So this is the part of the cycle where we actually get an ATP. So ADP to ATP. Okay, so this is just substrate phosphorylation. We're just taking a phosphate from this succinyl-CoA and sticking it on an ADP. Okay. All right, so once that occurs, we have our ATP, and the succinyl-CoA then becomes succinate. All right. The succinate then converts as well, and it converts to a molecule called fumarate, because we're still 4-carbon here. And in that, we get an FADH2. Okay, so now we have fumarate, and then that converts to malate. All right, and then from malate, we go back to oxaloacetate. And when that happens, we end up getting another NADH. Okay, so I don't care if you know all of these constituents of the cycle. I don't care if you know all those, but you definitely need to remember. You certainly need to know acetyl-CoA, and it's 2-carbon. You need to know oxaloacetate, because that's what starts this thing. If that's there, then the thing can happen. It can bind to acetyl-CoA, and it becomes citrate. So those three you need to know. I don't care if you know isocitrate, alpha-ketoglutarate. You'll see alpha-ketoglutarate again shortly, but I don't care if you know all these other ones here. Okay, but you definitely need to know those three, and you need to know what we get. Okay, so in the citric acid cycle, so let's just look at totals here. Okay, so we had, let's look at the grand total. Okay, so in glycolysis, we got 2 ATP, and we got, was it 1? Hold on. I can never remember. 2, sorry. 2 NADH. Okay. And then, of course, we got 2 pyruvate. Brought pyruvate into the citric acid cycle, and it went through the transition reaction. And in that, we got 2 NADHs, and then, of course, 2 acetylcholines. And the acetylcholine went into the citric acid cycle, and we ended up getting 1, 2, 3 NADH, 1 FADH, 2, and 1 ATP. All right, but you know we have 2 acetylcholines, so we really got 6 NADHs, 2 FADH2s, and 2 ATP. Okay, so grand total, we have 2, 4 ATP, we have 2, 4, 10, is that right? Yeah, 2, 4, 10. 10 NADHs and 2 FADH2. And then, of course, we have those 3 carbon dioxides, but they're going to be breathed off as waste. Okay, so doesn't seem like we got much out of this because we only got 4 ATP. But that's not really what's important here. The important thing is the high energy electrons we collected, because these are going to go to the electron transport chain, and that's where we're going to cache them in and get lots of ATP. So let's look at that.